Today we will start with PIR sensor. Okay. So last time we have seen what the PIR sensor is. PIR sensor is passive infrared sensor. It is also called as a motion sensor. And we have seen that this type of sensor is capable of sensing infrared radiation emitted by living being. Okay, so generally, human beings they radiate at wavelength 9 to 10 micrometers, and these PIR sensors are tuned to detect the infrared waves of wavelength 9 to 10 micrometers. So it is capable of detecting human being when human being arrives near it. Okay, so basically, it is not capable of detecting static presence of human being, but it will detect the motion of human being. If human being is moving, then and then only it can detect the presence of human being. So this is what PIR sensor is. Okay. Now, uh, as you can observe on the screen, these are the elements of PIR sensor. So here you can observe the first element of PIR sensor is Fresnel's lens. Then there is a filter. This is optical filter. Then there is sensing element and amplifier and comparator. Okay. So everything is cased into a single device. So these are what are the elements of PIR sensor. Okay. Now here we are going to study function of each and every block or element of the PIR sensor. Okay. So let us see what is use of Fresnel's lens array. It is not a single lens, but it is array of lens. Okay. So why it is used? Obviously, it is used to capture the more infrared rays and focus it on the relatively smaller point, as you know. So infrared rays which are emitted from the human being, they are sprayed, okay, and they should be combined together, focused together, and they are made to fall on a smaller point because your sensor size is very small. And if you do not use lens, then sensor will not be capable of detecting such a weak signal. And therefore, what is done? The lens is used to concentrate all these waves at a smaller area. Okay, and this is what is the functioning of Fresnel lens array. So what happens due to this, as rays are concentrated to a smaller area, the sensitivity of the sensor increases. At the same time, the range of detection, so it will also increase. So with help of Fresnel lens, the sensor is capable of sensing the devices, sensing the human being which is present at a longer distance. So this is what is objective of adding Fresnel lens array to the PIR sensor. Okay. Now the next element that we have seen is, which is present at the top of sensor, is in infrared filter. So it is optical filter which allows only infrared rays to pass through it, because you know uh, the PIR sensor is placed in a room. Then in a room there is ambient light, and your sensor should not be sensitive to this ambient light. Okay, so it will act as noise or interference to your PIR sensor. To eliminate it, so all remaining wavelengths they must be blocked, and only infrared waves which are having wavelength in the range of infrared rays which are emitted by human being. So only those 8 to 14 micrometer wavelength. they are allowed to pass through this filter. Okay, so as we are using this sensor to detect human presence, it is necessary to choose this wavelength from 8 micrometers to 14 micrometers. Okay, so this is the purpose of the infrared filter, why we are using it. Okay. Then you can observe there is a sensing element, and this sensing element is typically made from ferroelectric ceramic material. Okay, so it contains lithium tantalite, and nowadays it is made lead free for eco-friendliness. Okay, so actually what is done, instead of using a single sensor, a multiple sensor array is used here, again to increase the sensitivity of the sensor as well as to increase the area, sensing area. Okay, so basically the commercially available sensors, they use quad type of sensing element, which consists of four sensing element which are connected in array. Okay, so when IR rays, they pass through filter, what happens, only infrared rays which are in a range from 8 micrometer to 14 micrometer, they are allowed to strike the sensing element. So these sensing elements are pyroelectric sensing element, means the IR ray, as they are generating heat. So this heat will be converted into electric charge by this sensor. Okay. So the magnitude of the charge produced here is directly proportional to the intensity of IR light falling on it, falling on the element. Okay, so this is what is the basic principle behind the sensing of the uh, sensing element which is used in a PIR sensor. So basically pyroelectric sensor is used in it. Okay. After charge gets developed, this charge need to be amplified, obviously, because the amount of the charge generated will not be useful for us to drive the further circuit, and therefore there is a need to amplify this. And for this, on-chip amplifier configuration is available. Generally, operational amplifiers are used to amplify the charge which is generated by the sensor. And this amplified voltage is applied to comparator. So comparator is going to compare the formed voltage with some predefined voltage level. Okay, so generally two predefined voltage levels are programmed into this. One is a positive pulse and another is a negative pulse. So if the voltage produced is greater than this positive pulse and less than a negative pulse, which is pre-decided, then and then only the signal is generated by this PIR sense. Okay, so this is how the PIR sensor works. Okay, do you have any doubt in this? Yes. Okay, so we will move to the next point. Now here, what you can observe on the screen. Can anybody tell me? So this is a PIR sensor along with Fresnel lens, and you can observe the detecting area shown by two colors. One is pink and another is green. So when a human being enters into this detecting area, so basically two beams are detected. One which is shown with the uh, pink color and another which is shown with the green color. So there are two sensors in pink area and there are two sensors located in this green area. So these sensors are responsible for detecting the infrared rays emitted by human being. And as you can see here, as the living being moves across the sensor, the heat source is sensed by PIR sensor. So when it moves across pink beam, it generates a positive peak signal. And when it moves across the green beam, it generates a negative peak signal. Okay, so this positive and negative differential voltage will be produced. Positive and negative differential voltage will be produced by PIR sensor. Okay, so such type of differential voltage is generally generated. Not a single pulse, but two pulses are generated by PIR sensor. One positive when the human being is entering the area, and another negative when human being is leaving the area or a human being remains stationary there. Okay, so this differential type of voltage is generated by PIR sensor, because designer should know this type of voltage is generated by PIR sensor, because we are going to build application using this PIR sensor during your second year studies. Okay, so in embedded systems, we are using PIR sensor and we are building a application for either for automatic on and off of light, or for um, uh, intruder detector alarm. So these applications can be built with the help of such type of sensors, and we are going to study it. Now, here you can see what are the applications of PIR sensor. So you must know these. Okay. So as you know, they sense human motion. They can be used in automatic doors in elevators. Okay, and shopping malls. So you might have experienced these automatic doors. So when human being approaches near these doors, they open. Okay, once a human being enters the door, they close. Okay, so these are built using PIR sensors. Okay, burglar alarm at house and shop. Burglar means thief. Okay, so somebody who is not allowed to enter, if he is entering at house or shop. Okay, so this can be detected with the help of PIR sensor. So automatic lighting system, if somebody enters into the room, automatically lights turn on. So this is called as automatic lighting system. Even electronic amenities in washroom, when you bring your hands near the tap, automatically it switch on. Okay, so even in toilet, such type of PIR sensors are used to automatically flush the water. Okay, so these are some of the applications of PIR sensor. Okay, so are you clear about this?
Yes, ma'am.
Okay, now we will move to the next part of our syllabus, and that is a smart sensor. So here you can observe a picture of smart sensor. What it consists of, can anybody tell me what you can observe on the screen? Yes, what you can observe on the screen? Tell me. What is this? Have you seen such type of device? See, this is nothing but PCB. What is meaning of PCB? Can anybody tell me? Yes, can anybody tell me what is meaning of PCB?
Printed circuit board.
Printed circuit board. Correct. So on this printed circuit board, some ICs are mounted and other circuitry is also present. So that is what you can observe. ICs means, ICs means what?
Integrated circuit.
Integrated circuits. Okay, so smart sensor is a sensor which is built upon such printed circuit boards and associated circuitry. Okay, so what makes the sensor smart? So there is computing facility available with the sensor, and this computing facility which is available with the sensor makes it smart. Okay, so what it does, it takes the input from the physical environment, and it uses this input with built-in computing sources to perform certain predefined functions upon these detected signals, and then processed data is made available at the output. Okay, so if your sensor is capable of doing this, then that kind of sensor is called as a smart sensor. So adding computing facilities to the smart sensor makes it smart. Okay. So if it is capable of performing some predefined function, that means you are programming certain functions on a chip. And this chip is going to process on the signal that is detected by the sensor. So that is what is happening in the smart sensor. Okay. So now let us go to next slide. So here what you can observe, block diagram of smart sensors. Okay. So there may be a single sensor or there may be array of sensors. Okay. Array of sensors along with certain components. You observe different components. And these components are present in the processor, which is there located on the printed circuit board of the smart sensor. So normally these smart sensors have three important parts. One is the sensing element, and second is obviously signal processing circuit. All of you have studied what the signal processing circuit is, and it has a processing circuit also. Processing circuit means it is basically a computing circuit, okay, and a interface, okay, which is going to act as intermediate between the user end and the sensor. So sensor interface is also provided. Now, in a diagram, you can see the processor may consist of a multiplexer. Multiplexer function of the multiplexer is to connect multiple sensors to the single output. Okay, so at a time it is going to select one sensor and give it to the or provide it to the single output. So that is what is the function of the multiplexer. So if you are using multiple sensors, then you have to use multiplexer, uh, the processor which consists of multiplexer. Okay, so this multiplexer is powered by the current source, and output of the multiplexer is given to analog to digital converter, because as you are going to process the signal, most of the signals available from the sensor, they are analog in nature, and as you are using processor which is uh, working on digital technology, so there is need to convert the analog signal which is available from the multiplexer to corresponding digital value, and this digital value is applied to what is called as DSP. DSP means it is a digital signal processor. So this digital signal processor is responsible for performing mathematical operations on the signal which we get out of the sensor, and desired form of the signal is made available at the output, which is called as a sensor interface. Okay, so this is how the smart sensors are built, and this is how they work, and this is all about smart sensors that you must know. Okay, now number of technologies are used to build such type of smart sensors. So one thing you can observe on the screen, which is known as VLSI. VLSI means very large scale integration technology. Okay, so the devices that are part of this micro electromechanical systems. They are developed with the help of technology, which is called as VLSI technology. Okay, so the components which are able to perform both mathematical and electrical functions, they are integrated onto a single chip, and amount of integration decides whether it is very large scale or not. So number of components which can be integrated into VLSI technology is considerably large. Okay, so generally smart sensors are fabricated using VLSI technology. Now, apart from this, wireless sensor technology is also widely used. So output which is available in electrical form is converted into radio waves with help of these wireless sensors. So there are wireless sensors which convert the electrical output into electromagnetic waves, so that there is no need of wires to connect that sensor. Okay, so remote sensing, particularly for remote sensing, the wireless sensors are used. So two important technologies which are involved in the fabrication of smart sensors are VLSI technology and wireless sensor technology. Now let us go to applications of smart sensors. So can you observe various applications of smart sensor on the screen? Can anybody tell me it? Yes? Here's what you can observe on the screen. Can anybody tell me? Read it out loudly. Yes, Atharva, can you read it out loudly? First application,
Communication.
communication. Okay. So what is meaning of communication? Can anybody tell me what is meaning of communication? It is nothing but an exchange of information. Okay. So if you want to have information about some physical environment, or if you require information about a certain chemical process. So, such type of application is called as communication application, and in communication, the smart sensors are used. They are also used in multi-sensing applications. Okay, so basically, multi-sensing applications are data acquisition systems. Okay. So data acquisition systems, they are capable of acquiring multiple type of data. For example, temperature, humidity, uh, and sort of other parameters like this. Okay. So if it is capable of sensing multiple type of parameters, then it has a multi-sensing capability, and this multi-sensing capability is added to your smart sensors. So in such type of applications, smart sensors are used. Now they are capable of providing you with the computation facility. Okay, and they are also capable of providing you the self calibration, because they have internal circuitry or programs written for the calibration of quantity. So these two important advantages of smart sensor are there: computation and self calibration, and multiple sensing, and it also can provide the communication. Okay, so these are advantages of the smart sensors. Okay, now after this I'll be sharing one more screen with you. Now, can you observe something on the screen? What you can observe? What is written over on the screen?
Of
What is this?
motion
Remote.
sensor or PIR sensor.
What is this? Can you read it out? What it is? Engineer's Garage. It is website which provides information about different electronic components. Okay, and it also provides insight of particular electronic device. So these insights we cannot see, because in order to see these insights we have to break the device. So instead of doing that, if you observe it virtually, then you will come to know what is there inside. Okay, so what is this? As you can see, which type of sensor is this? Can anybody tell me? Can you identify this sensor? What is written over here? Yes, tell me.
PIR sensor.
This is a PIR sensor. This is PIR sensor. And this outside case. So this is a Panasonic PIR sensor. And this outside case, it shows the Fresnel lens array. So plastic like cover you are observing is a Fresnel's lens array, and it has different pattern over it, just like mosaic. Okay, so this is what is Fresnel lens array. So here you can observe the actual device. Okay, so this is so small device, and within this there is actual sensor, and two terminals are given out to connect it to the remaining circuitry. Okay, so here you can observe the sensing element. Now here you can see the plastic molding is removed, and when you remove the plastic molding, inside this you can observe the actual device. And here you can observe something which is square in a shape. Okay, so this part is nothing but this hole is a PIR sensor. Okay, this hole. This is the shape and structure of the PIR sensor. And as you can see, the package used for it is metal can type. This type of package is called as the metal can type of package, and it is a TO5 type of metal can package. And the square patch that you observe over the sensor is the IR filter. The square patch is a IR filter of the sensor. Okay, so now can you see the size measurement of this particular sensor? It is having diameter of 8 mm and height of 4.2 mm. So such a small size it has, less than 1 by 1 centimeter. Okay, so now if you break the sensor, so this IR filter is broken here, and inside you can observe the sensing element, and how it is how the sensing element is. Just it looks like a simple piece of wire, okay, connected between two contact points, two contact metal points. So this is actual sensing element, and this sensing element is pyroelectric sensor. Okay, and this remaining thing is a PCB, that is a printed circuit board of a PIR sensor. And on the printed circuit board of PIR sensor, the different components are mounted, and these different components are amplifier with help of FET and comparator with help of operational amplifier. Okay, so you uncap this, you can observe these different elements which are present over there. Okay, so FET is shown here. FET is field effect transistor, and that field effect transistor is used as an amplifier. Okay, so this is a base plate. Okay, and these are the remaining components. So even you can open this engineer's garage and you can see whatever you want to see inside of different devices you can see with help of engineer's garage. This is a very good website. Okay, processor unit is shown here. So different components along with resistor, operational amplifier, field effect transistor, and different resistors. They are used to form the processing circuit of the PIR sensor. If you observe the output terminals of PIR sensor, then there are only three terminals. This terminal is a drain terminal, which is ground terminal. This is a source terminal, which is your output terminal, and gate terminal is power source terminal. That means between this ground and gate terminal, you have to apply external power supply, and you can take output between this ground terminal and source output. Okay, so these two terminals are output terminals, and these two terminals are where you have to attach a power supply. Okay, so, so are you clear about this?
Yes, ma'am.
Because next year you are going to build application with help of this, and even you can undertake the hobby project like building motion sensor in parking area, or building automatic light in a bathroom, like that. So you can build a application with help of this. Okay? So today we shall stop here, and next point we will be studying on Monday. Okay. So how many students are there? I will end the meeting now.